All right, so we're going to move on to the slope-intercept form, which we have actually started to see already when we did that Hitting the Slopes worksheet in class the other day. And you'll see that we don't need a whole lot of information to be able to graph, especially once we have our slope-intercept form. So we know that the slope of the line is 2/3, and the y-intercept is equal to -1. So let's see if we can put that information together and actually graph a line. Well, I know that my y-intercept is at 1, so that means my y-intercept along the y-axis is right there at 1, and I know that I have a slope of 2/3. Well, my slope of 2/3 means I have a rise of 2 for a run of 3. So I can go up 2 and over 3. I can go up 2 and over 3, and magically, if I could draw a straight line, I have the line that represents my function. So this time I know I have a slope of a line that's -3, and the y-intercept is again at 1. Go ahead and graph our y-intercept, and our slope is -3, which means either my rise or my run is going to have to be negative. So I'm going to go down 1 for my rise, 1, 2, 3, and plus 1. I could have also gone positive rise, 1, 2, 3, and a negative run. Either way, I had to have 1 be negative and 1 be positive, and you'll notice that when we connect those points, I do have a slope that is negative. We've seen charts that look like that, graphs that look like that. Okay, so slope-intercept form. This is probably the most popular way to express the equation of a line, and we're going to see this all the time. Y equals mx plus b. M is the slope, b is our y-intercept, and we saw that before when we did the hitting the slopes, that we could cover up mx to see where the intercept was. So the y-intercept, jump over to this b, and we also saw that the coefficient to our x was the slope of our line. So if I know that I have a slope of 3/4 and a y-intercept of 5, I could write that as y equals slope times x plus my y-intercept, 5. Okay, I've got another one. Slope equals -1 and y-intercept equals -3/5. I'm going to try to go through these quickly. So I've got y equals -x, because I've got a -1 slope, plus a -3/5, or more generally, we're going to write this as -x minus 3/5. I'll take it either way, but this is probably the way you're going to see it the most. Okay, slope of -2 times my x plus an intercept of 0 could also just be written y equals -2x. The 0 would be assumed, so my y-intercept is at the origin. Intercept is -2. Slope is 0. So 0 times an x is going to make my x disappear. I have a y-intercept at -2. So I actually have a line where y equals -2. Okay, what if we're given the slope and a point on the line? Well, I can take care of that. I know that my slope is 2, so let's go ahead and fill in what we know. I know that y equals 2 times x plus b, and we don't know what that intercept is. That's what we're going to have to find. So I need to figure out how to find b. Well, what I can do is, notice here I've got an x-coordinate and a y-coordinate, so I can plug these numbers in for my x and my y and solve for b. So if my y equals -3, then I've got -3 equals 2 times 1, plugging in for my x, plus b, and then I can solve for b. -3 equals 2 plus b, so b equals -5. Then I can go back and rewrite that equation. y equals 2x minus 5, and that would be my final answer, my final equation. Slope is equal to 2, and I have the point 34. Y equals 2x, my slope, plus b of some sort. I'm going to plug in my 3 and my 4. 4 for y equals 2 times 3 for x plus b. So 4 equals 6 plus b. Therefore, b equals negative 2. So I have the equation y equals 2x minus 2. Okay, so why is it that I want this slope-intercept formula? Why is this so important? Well, let's say I have an equation, y equals negative 3x plus 2. I know right away, remember this is y equals mx plus b, my m being my slope and my b being my y-intercept. I already know that I've got a y-intercept here at 2, and I've got a slope right there of negative 3. So my slope equals negative 3. I know that I can find this by going down 3 and over 1, or up 3 and back 1, and I can actually graph my line. Here's another example. X minus 3y equals 12. Well, this time I've got it in standard form, and we've done a lot of practicing going back and forth between standard form and what we used to call the y equals form, which we now know is the slope-intercept form. So I can just put this back into slope-intercept form. So x minus 3y equals 12. I'm going to subtract x from both sides. I've got negative 3y equals 12 minus x, divide by negative 3, and I get y equals negative 4 plus 1/3 x. And of course I can rewrite this in the form the order I'm expecting, which would be y equals 1/3 x minus 4. Okay, so now I have my y-intercept and I have my slope. So let's pull up a graph here. So I can graph my y-intercept here at negative 4. I have a slope of 1 over 3. So I have a rise of 1 for a run of 3, a rise of 1 for a run of 3. So the equation as a line looks like that. 2y plus 3x equals 6. Pause the slide, see if you can do this on your own. And I'm going to graph my y-intercept of 3 and my rise, negative 3, and a run of 2, or going the other direction. Okay. Always like throwing in a real-world example. Here I've got a caterer that charges a $200 fee, plus he charges $18 per person served. The cost as a function of the number of guests is shown in this graph. We need to write an equation that represents the cost as a function of the number of guests. Well, remember, I've got my slope-intercept form, y equals mx plus b. I can get my plus b, that's my y-intercept, and I'm looking over here and it looks like my y-intercept is at 200. So far I've got my y-intercept, and I need to find my slope. Well, we know how to find our slope. We can look at rise over run. Okay, so this point right here, it should be at 290. So we could see that our slope was our rise, which was 90. Our slope is 90 over 5, which is our $18 per person. So our slope is 18 times x. So in fact, it will ask me now, to identify the slope and y-intercept, but to describe their meanings. Okay, so I've got my y-intercept, and that y-intercept of 200 means that I have that initial cost. I can never spend $0. The least amount I'm going to spend is $200, and it'll go up from there. So my y-intercept represents the money I'm spending just to have this party, to pay the caterer just to have a party. My slope is representing the difference in cost for each additional person that I add. So 18 as my slope means the cost is $18 per person, my cost over the number of people. So my slope of 18 is the cost per person. My y-intercept of 200 is the initial fee paid to the caterer. Go ahead and write these equations in slope-intercept form. Pause the slide. I'm just going to write up your answers. There's an online quiz, has some quick questions, and tomorrow we will continue practicing with slope-intercept form.